I've been working on this charge and sand project for a while, and I'm at a point where I've finalised all the processes for making each component. At this stage, I've started creating duplicate moulds using the mould shells from the previous videos and started casting some components to get a rhythm and a feel for the workflow. From here, I want to focus on refining each process to maximise efficiency and productivity for a one-man operation. I've taken this approach with every step so far, and there are obvious limitations to doing this by myself. But there's still some things I can implement, like jigs and fixtures, to get the most out of my time. There's two main variables I can adjust: increasing the number of moulds or speeding up the turnaround of each cast. For the front body, I've designed a jig shaped as the negative of the component. This will allow me to demould it at the gel stage, and it'll be able to fully cure without deforming. This approach reduces the time between casts and means I won't need to create a lot of duplicate moulds. The main body can't be demoulded at the gel stage without risking deformation, so adding more moulds is the best approach for this component. I've created a jig shaped like the lower outer shell to hold the mould while it cures, freeing up the main matrix shell so I can continue casting into the duplicate moulds. I'll be printing these on the BambuLab X1C that BambuLab sent over. I'm sure everyone's very familiar with BambuLab and their printers. These pretty much reset the industry standard for fast printing while maintaining quality. Speed and accuracy are definitely appreciated in my working environment, especially with the goal of efficiency. This has the AMS for multi-material or multi-colour printing, which isn't something I'd usually utilise, though it's something I might explore in the future. I do appreciate the convenience though of being able to load up my most used filaments and having them automatically load themselves in. I'm printing these in matte PLA. I primarily use ASA for all my FDM prints, as I'm usually making components with mechanical functions, like load-bearing brackets for example. However, since these jigs aren't under any kind of load, PLA is going to work perfectly. Since starting this company, I've always used FDM printers. These days, I mainly rely on them for specific components of my automotive products, but moving from my older printers, which typically run really slow, to this has got me reconsidering how I could integrate more FDM printing back into my workflow. The speed of this makes it more viable for producing parts I previously avoided, just really due to long print times. BambuLab is currently running a Black Friday event until December 3rd, so if you've been considering the X1C or any of their other printers, I've left links in the description where you can find more details on the printers and any discounts. After I've printed these, I can get all the supports removed and glue the magnets in. I've designed these in a way so they're stackable to keep everything nice and organised, and if I need more, I can just keep adding to the stack. I've printed a couple of main body jigs as well. This is actually my first time using organic support. I think I need to dial in the settings a little bit more, but it's interesting and I appreciate the efficiency. Now these are prepped, I can start implementing them into my workflow. I won't cover every detail of these moulds as I've covered them in depth in the previous videos, but the main body mould has a printed tube that's set into the mould before casting. This creates a cavity for me to run the cable of the MagSafe charger through the body. I'm casting these using my PU01 polyurethane resin, which is pre-pigmented black. This resin doesn't strictly need to be degassed, but I always say if you've got access to a vacuum chamber, it's definitely worth doing. Once mixed, I can pour the resin in, place it into the pressure pot and let that sit until the resin starts to gel. Once it's gelled, I can take it out of the pressure pot and then remove the mould from the shell. This is where the jigs come into play. As I mentioned before, I can't remove the component from the mould at the gel stage due to the way I have to take it out. Removing it too early would cause the component to deform either from me handling it or under its own weight when it's sitting freely on the side. So it must remain in the mould until it's cured enough. The jig replicates the mould sitting in the lower shell, so it'll retain its position while I use the main shells for the next mould. Having 3 moulds in rotation seems to be a sweet spot for this workflow. By the time I've removed the 3rd mould from the shell, after removing it from the pressure pot, I can remove the component from the first mould and then continue the cycle. Now I can move on to the front bodies. These moulds have threaded inserts set into the mould before casting, so they'll be over moulded in the process. I'll follow the exact same process as the other mould, degassing the resin and using the pressure pot. I'm only cycling 2 of these moulds, as the turnaround is really quick between the 2. Because there's very little force needed to remove them, I can remove them at the gel stage, freeing up the mould. You can see how soft these are still at this point. By placing them into the jig, the component will be supported in the same way as if it was still in the mould. This means I can demould these really in around 10, maybe 15 minutes after casting. I can keep cycling these to a point where the first one is cured enough for me to be able to remove it from the jig and set it aside, freeing up space for the next one. Ideally, I'd print even more so I can keep them stacked and organised. But for now, even having 8 of these in rotation has really increased the efficiency of this part of the workflow. So I think it's worth mentioning that all these jigs and shells and everything aren't necessary to have in place to actually do these processes. These are just things that I've put in place that work for me because I know what my pain points are when it comes to doing all this. So if I look back at the past decade of mould making, I know that in the early stages when it's designing parts, or designing shells and everything, I really enjoy that stage because it's problem solving, it's always new along the way. But then when you get to the end where you've either got to make another mould because that one's expired, or make a duplicate mould, or the repetitiveness of casting, that's the point where it changes. It just doesn't stimulate me the same as those early stages because all the problems are solved. So by having these in place for me, it just takes a lot of the friction out of doing those things that feel more like work. So if I had to manually do a mould, that would be very difficult for me to even start because I'll list off all the steps, and there's 20 steps in that. But then with these, it's like I've got a shell, put the dowels in, bolt it together, and then that's it. So for scalability, that's really good as well because I've only got to do that once up front, and then indefinitely making moulds is just really easy for me. Same with the jigs. I'm inherently not very organised. Usually when I've done a big casting session, I'll have parts stacked everywhere, and having the jigs in place, although the efficiency of being able to take them out the mould quick, that's great. But the fact I've got a place for things to go now is also something that is just taking the friction out again. The next process is to cover the multi-cavity mould for the pads that go on the underside of the charging stand. This is a process that will really benefit from being optimised, as they have to stay in the mould for hours before I can demould. So running multiple moulds will give me more components over the same time period. Previously, I was pouring in half the resin, degassing that in the mould to remove any air from around the details and text, then filling them up to level, then putting the inserts in. I want to try and reduce this down to a single pour moving forward to remove that extra step. I've designed a paddle with locators for the mould to sit on, keeping them in place, and it's also got a protruding area at the front so I can pick it up easily. I've roughly calculated that I can handle 4 of these moulds in a single pour. So I've designed a rack for the paddles to slot into, keeping everything organised and manageable. I'll print this again on the X1C using the same PLA. Given the long cure times of the flexible polyurethane, these components would benefit from post-curing at 80 degrees for a few hours to speed things up and achieve a full cure. Though typically this brings risks of shrinkage and surface defects if post-cured while still in the mould. If I went that route, I'd want to print an ASA version to withstand those temperatures. However, I'd be more inclined to let these cure naturally to avoid these drawbacks and instead make another set of moulds and rack to rotate through. With that said, I think 16 components is a good number to achieve in one operation. Once it's finished printing, I can remove the supports. I've laser cut 4 paddles and locators that are glued in position. I've also designed a handle for the rack. This is so I can lift the entire assembly into the vacuum chamber once the resin is poured. To attach the handle securely, I'll be using my heat press and some brass threaded inserts. This little heat press setup includes a soldering iron with heat set insert tips and a Dremel drill press. I originally bought these with the idea of adapting the soldering iron to fit into the Dremel press. I chose a soldering iron with a threaded section on the front, which was meant for a cover, and I plan to design and print a threaded adapter to hold the soldering iron into the drill press. But to my surprise and slight disappointment at missing out on doing the project, the Dremel's adapter had the exact same thread as the soldering iron, so it worked right out of the box with no modification needed. I'll include some Amazon links in the description to each component of this setup, just in case anybody else wants to do this themselves. Now that's all finished and attached, I can make a start on getting these cast. Currently, I'm midway through making duplicate moulds, so I'll briefly run through this process as I still have one more to make. Again, I've covered this process in the previous videos, but I printed a mould negative that I can pour straight into to give me a finished mould. I'm using my AD28 silicone, which is an addition cure silicone with a Shore hardness of 28A. I'll degas this first in the mixing cup. Then I can pour it into the mould enough so the details are covered. I'll then put the mould into the vacuum chamber to remove any air trapped in those details, similar to the process of actually casting the resin into these moulds. Once I'm satisfied, I can take that out and fill it up to level. The turnaround for this is relatively quick, at 1 to 2 hours for a full cure, depending on the ambient temperature. You could accelerate the cure with heat, but I never like to do that due to the expansion of the master. If there's precise tolerances in the mould, then these could be thrown out quite easily. Now that's cured, I can make a start on getting these into position so they're ready to cast into. So before committing to this, I thought it's probably going to be a good idea to test this with the original mould, just to make sure this method is actually going to work. I'm glad I did, because what I thought might happen did happen. Even with pulling a vacuum really slowly, the inserts have lifted and it's created a bit of a mess. So it looks like I'm going to have to go back to the original method of filling them up halfway, degassing that, take them out, fill them up to level, and then put the insert in. This is obviously put the step back in that I was trying to remove, where I had to do 2 pours, but if that's the method that works, then that's what it is. I'm still going to get 16 components per casting session. The other method I could try would be to pressure cast them, so just do 1 pour as I was going to do, and then pressure cast that. But because of how long these take to gel, it's just going to tie up the pressure pot. So yes, that process would be quicker, but that would delay me in other areas. So if there's a slight compromise of having to take the trays out of the holder just to fill them back up, then it is what it is. To start, I can set one of the moulds onto the scale and mix the resin. The idea with the scale is to keep everything consistent and to ensure I don't overfill each cavity. In reality, this was incredibly difficult the first time round. I'm going to put this down to feeling under pressure and conscious of the fact that I have several camera moves to do during this process. So quick maths from slightly overfilling the first one completely went out the window. I think without that pressure, I could take things slightly slower and be a bit more precise. Once all the cavities are filled and the rack is loaded up, I can place the entire thing into the vacuum chamber. You can see with them only being partially filled that it doesn't overflow and cause a mess like before. Now it's done, I can remove each mould one by one, pour in the remaining resin, and then set the inserts into position. This resin has a pretty long pot life, so I can just about get this done before the resin starts to gel. Now they're done, I can leave these in the rack, set it aside and let them fully cure. While they're curing, I can move on to prepping the cast parts. In the interest of getting through filming, I stopped casting at a point that I felt I had enough components to demonstrate the workflow. In practice, I'd likely carry on and have more components per batch. The prep work consists of dremeling off the port and air hole negatives, sanding them flat, and then painting what needs to be painted. Once the base pads have cured, I can remove those and prep them for the next stage of securing those into the main body. I love the finish on these. This was achieved by shot blasting the master with 120 grit aluminium oxide. It gives the finished component such a clean, matte surface texture. These are prepped simply by snapping off the tabs that were used to suspend and locate the insert into the mould, then sanding off any excess resin. This next step is something I've been looking forward to. I need the main body to be held upside down with the opening level. So I've printed these little holders that slot into some aluminium extrusion, allowing me to have these securely lined up, ready to do some batch pouring. Immediately, one change I would make to this is to have the main body locate onto these holders with some kind of hook or piece that goes through the tube and locates it tightly, rather than screwing them on. Although they're very secure, doing this many is a pain and unnecessarily long-winded. Once they're all attached, I can flip them over and clamp the extrusion to the workbench. I also incorporated a holder for the base pad to slot into each one. Again, all in an effort to keep the workflow organised. As before, I'm adding steel ball bearings to each cavity in the main body to give them some additional weight for stability. Then I can mix up some more PU01 resin and pour this into the base. This will stop the ball bearings from rattling around, setting them in position, as well as acting as an anchor for the base insert once it cures. The pins on the insert submerge into the resin, setting it in position. I can continue moving along the line, filling them one by one. I'm doing 10 at a time in this batch, which feels like just the right amount to get this done before the resin starts to gel and becomes unpourable. Now they're set, I can remove them all from the jig and assemble them. If you've watched any of this series, I know you'll have seen the assembly multiple times by now, so you know how this goes. Really, all that's left to do is attach the front body and the charger holder. I've got the original design for the original MagSafe charger, and I've also designed a new version for the 2nd gen charger that's recently been released. As before, the flexible pad goes over the charger holder, and the cable insert on the back can be installed to finish it all off. So that pretty much covers all the processes involved in making these. I'm happy at this point with where the workflow is, and that I think I've managed to make them as efficient as possible, each of the steps. Don't think there's much more I can do in that regard. There is one step that I've missed, which if you've watched any of the previous videos, you might have spotted it, which is the front pad. So although that mold works, it is a bit of a tricky one to scale, just because you've got to be so precise with the way that you have to put the mold together. You can't really have a multi-cavity mold for that, so they would have to be individual molds, but because the flexible polyurethane takes so long to gel and it needs pressure casting, that is just going to tie up the pressure pot. So I'm really going to have a think about that one. If this is a limited run thing, which it still might be, then I can probably persevere with that and just pick away at them. But if this ends up being sort of a permanent product that I do offer, I probably will have to outsource that, which kind of pains me to do because I've never actually outsourced anything I've made. But if that's the route it's going to take, I need to be realistic. I can't do them the way I have been doing them at scale. Although this is the final video in the series on the charging stand, I probably will come back to it at some point and give some updates. I think I said in the last video that I'm picturing the main body being like a standard default piece, and then I want to explore different variations of the front, just out of different materials, different finishes, different concepts, keeping that same sort of silhouette, but just doing different variations. If you want any updates on the release of these and different versions of the front or different stuff I'm working on in the future, there is a link to my newsletter in the description, so you can sign up there. I appreciate anyone who's watched this from start to finish, who's literally been following it along. I know it's been sort of a long-winded process. On the outside, it looks like this is all I've been working on, but I've been picking away at this between work and other work I do. This is still work. So I think I'm doing it like a Q&A next month, just to give people a bit of a look inside and get to know the inner workings of what I actually do. Because I understand I've just popped up and doing these charging stands. So that's coming. If you want to drop any questions in the comments, please do. Just give me some things to go off. But yeah, I appreciate all the support so far, and thanks for watching.